Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this video I will solve the problems of assignment number 1 that was provided in the part 1 video as part of the concept that I discussed on general rules to solve problems of time and work. If you have not watched the part 1 video, then I strongly suggest and request that you please watch that video where I discussed about the two general rules that are used to solve the problems on time and work. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in the solution of problems of assignment number 1 on the chapter of time and work based on the general rules. Okay, so I have the problems written down. These are the problems that I gave as part of the assignment number 1. There are 10 questions, and most of them are MCQ, that is multiple choice questions where one choice will be correct, and few questions are fill in the blanks. Now, I always say that after solving a set of problems, you must always revise all the key concepts and formulas that was used in solving the problems. I will not do, I will not do the recalling of the formulas and the concepts used because that will take a lot of time. But I have done a few videos where I think in the for the chapter of compound interest, where I showed after solving a set of problems how you will recall the key concepts and formulas that was used to solve them. If you do this every time, then you will have a consistent revision of the old chapters, and also the concepts and formulas will stay in your mind for a longer period of time. So always do this while you are solving an assignment sheet, or any you are giving a mock test, or even you are solving problems of any exercise from your textbook or any other reference book. Okay. So the first problem says that A alone can finish a piece of work in m days. B alone can finish the work in 2m days. Then time taken to complete the work by both A and B working together is. Okay. So the space that I have kept for solving each problems is not that much. So I might struggle in the spaces might be insufficient to do the solution, but I will try my best. So I have to write a little smaller. I hope you will be able to, it will be visible enough, it will be big enough so that you can see my solution properly. Okay, so the number of days that A and B alone can finish a piece of work is given. So we can say that is one day's work is one day's work means the amount of work done by A alone in one day. Is one day's work will be equal to 1 by m, since it is given that A alone can finish a piece of work in m days. Similarly, B's one day's work will be equal to 1 by twice m, since it is given that B alone can finish the work in 2m days. Now, using these two facts, we can say that A plus B's one day's work, which means that the amount of work that will be done in one day if A and B both work together. So A plus B means A and B are working together. A plus B's one day one day's work will be equal to 1 by m plus 1 by twice m. This is equal to 3 by twice m. So in one day, the amount of work done is 3 by twice m when A and B are working together. So now we can say that. So in one day, so now we can say that this implies A plus B can complete the work in now in one day the amount of work done by A plus B, that is both when both A and B are working together, is 3 by twice m. Now if we can write 3 by twice m, we can write it in the form of 1 by capital N, that is 1 by twice m by 3. So now we can say that then A plus B together, when they are working together, A plus B can complete the work in twice m by 3 days. So the answer is twice m by 3 days, and hence the correct choice is choice D. D is the correct choice. Okay. Problem number 2. A can complete a work in X days after working for Y days where Y is less than X. I will quickly check whether everything is visible or not. Okay. So A can complete a work in X days after working for Y days, but now it is given that Y is less than X. After working for Y days, what percent of the work is still left? Now definitely if Y is less than X, then definitely after working for Y days, the whole work will not be complete, because the whole work is complete in X days by A. So some part of the work will be left, and we have to find what is the percentage of the work left. Now the percentage of the work left will be based on the whole work, which is always 1. Okay. Now, so we can say that is 1 day's work is 1 day's work, that is the amount of work done in 1 day by A is equal to 1 by X. Okay. Now it is saying that after working for Y days. Now we have to find how much work is done after by A in Y days. Okay. So A's 1 day's work is 1 by X. So this will imply that A's Y day's work means that amount of work done by A in Y days is Y days work. Simply using unitary method, we can say will be 1 by X multiplied by Y, which is equal to Y by X. So Y by X is the amount of work done in Y days by A. Okay. Now we have to find what is the work left. So this implies work left is the whole work. The complete work is always regarded as 1, and the amount of work that has been done in Y days is Y by X. So the work left is 1 minus Y by X. This is equal to X minus Y by X. So now we have to find what is the percentage of this work left based on the whole work, which is 1. So we have to find percentage, we have to find what percent is X minus Y by X of 1. Why 1? Because the whole work is 1. The question is what percent of the work is still left. Now the work left is X minus Y by X and the whole work is 1. So we have to find what is the percentage of X minus Y by X based on 1. So this is, it will be simply X minus Y by X multiplied by 100%. This is equal to 100 multiplied by X minus Y divided by X percent. So 100 multiplied by X minus Y divided by X is the answer. So The correct choice is D. Okay. Problem number 3. A and B working together can complete a work in X days. B alone can finish the work in 3x days. Then amount of work done by A alone in 2x days is the amount of work done by A alone in 2x days. Now, if we want to find the amount of work done by A in certain number of days, that is 2x days, we first need to find what is the amount of work done by A in one day. So, it is given that A and B working together can complete a work in X days. So, we can say that using the first principle, not using the first principle, that A plus B's 1 day's work will be equal to 1 by x, since it is given that A and B working together can complete a work in x days. Therefore, in one day the amount of work if A and B are working together will be 1 by x. So A plus B's 1 day's work is 1 by x. Okay. Also, we can say, since it is given B alone can finish the work in 3x days, we know that B's 1 day's work is equal to 1 by 3x. Now, what is A plus B's 1 day's work? A plus B's 1 day's work means A's 1 day's work plus B's 1 day's work is equal to 1 by x. Now, this implies, we know that B's 1 day's work is 1 by 3x. So, we can say A's 1 day's work plus 1 by 3x is equal to 1 by x. So, this implies A's 1 day's work is equal to 1 by x minus 1 by 3x, which is equal to 2 by 3x. So, A's 1 day's work is 2 by 3x. So, it is asking the amount of work done by A alone in 2x days. So, this will imply A's 2x day's work will be equal to 2 by 3x multiplied by 2x, which is equal to 4 by 3. So, 4 by 3 is the amount of work done by A in 2x days. So, the answer is choice D. Okay. Problem number 4. A and B alone, A and B alone can complete a work in 3 days and 5 days respectively. That is A alone can complete a work in 3 days and B alone can complete the work in 5 days. Now, after working together for m days, A leaves. If the remaining work is finished by B in 2 and 1 by 3 days, then value of m is. Okay. So, A and B alone can complete a work in 3 days and 5 days respectively. So, we can say A is what is happening. Okay, so we have done 3. We are doing problem number 4. Okay, so we can say that A is 1 day's work is equal to 1 by 3. Similarly, B's 1 day's work is equal to 1 by 5. So this implies A plus B's A plus B's 1 day's work, that is the amount of work done in 1 day when A and B are working together, is equal to 1 by 3 plus 1 by 5, which is equal to 8 by 15. Okay. Now, after working together for m days, A leaves. So we have to find how much work was done in m days when both A and B were working together. So we need to find the amount of work done by both A and B for m days. So we can say now A plus B's m days work is equal to 8 by 15 multiplied by m using unitary method. So if work done in 1 day is 8 by 15, then work done in m days will be 8 by 15 multiplied by m. So this is equal to 8 m by 15. So this is the work done in m days. Now we have to now find the remaining work. So after m days, work left will be, the whole work is 1 and the work done in m days is in 8m by 15. So the work left is 1 minus 8m by 15, which is equal to 15 minus 8m by 15. This is the work left which need to be finished by B. Now it is given that this remaining work, which is the remaining work is 15 minus 8m by 15. This work is completed by B in 2 and 1 by 3 days. Now let's see if we can find how many days the remaining work will be completed by B. Since we know that B's 1 day's work is 1 by 5. Now how many days in how many days B will complete the work 15 minus 8m by 15. So time taken by B to complete work left will be equal to, the work left is 15 minus 8m by 15. So how do we know what is the number of days that B will take to complete the remaining work when we know that B's 1 day's work is 1 by 5? It will be so 1 by 5, I really can't write because I do not have space. So 1 by 5 work is done by B in 1 day, and then we have to find how many days it will take by B to complete 15 minus 8m by 15. So using simple unitary method, the time taken by B to complete the work left, that is to complete the work 15 minus 8m by 15, will be 15 minus 8m by 15 multiplied by 5. The 5 is actually coming from 1 by 1 by 5. 1 by 1 by 5 is 5. So this is equal to 15 minus 8m by 3. So this is the now 15 minus 8m by 3 is the number of days that will be required by B to complete the remaining work, and the remaining work was 15 minus 8m by 15. Okay. Now it is given that the remaining work is completed by B in 2 and 1/3 days. So we can say that this 15 minus 8m by 3 is equal to 2 and 1/3, which means 7 by 3. 7 by 3. So we have to solve this equation, and then we will get m. If you solve, I really do not have any space. If you solve this, you will get uh, if you solve this, that is 7 by 3 is equal to 15 minus 8m by 3. If you can cancel the denominator 3 from both sides, you will get 7 equal to 15 minus 8m, and then you will get 8m is equal to 15 minus 7, which is 8. So you will get 8m equals to 8, and m will equal to, then m will be equal to 1. So this is the value of m. The value of 1 will be, the value of m will be 1. So the correct choice is D. Okay. Problem number 5. A can complete 1/4 of a work in X days. A can complete 1/4 of a work in X days. So this statement, you can consider as that A can complete 1 by 4 work in X days. Now, what percent of work will be finished by A in 3x days? Okay. So it is given that A can complete 1/4 of a work in X days. So what percent of work will be finished by A in 3x days? What percent of work will be finished by A in 3x days? Okay, so we are having A can complete 1/4 of a work in X days. So A's X days work is given, X days work is given to be equal to 1 by 4, because it is saying that A can complete 1/4 of a work. Now a complete work or a whole work is always considered to be, considered to have the value 1. So 1/4 of a work, if the whole work is 1, then 1/4 of a work will be 1 by 4. So we can say that in X days, it is given that in X days A is completing, the amount of work done by A is 1 by 4. So hence we are writing A's X days work is 1 by 4. So this implies that using unitary method, A's 3x days is 3x days work then will be equal to 1 by 4 divided by x multiplied by 3x, which is equal to 1 by 4x multiplied by 3x, which is equal to 3 by 4. So 3 by 4 is the work, is the amount of work done by A in 3x days. Now we have to find what is the percentage value of 3 by 4 based on the whole work, that is whole work is 1. So we have to just find what is the percentage equivalent of the fraction 3 by 4. So this 3 by 4 is equal to 3 by 4 multiplied by 100, this much percentage. This is equal to 75 percentage. So in 3x days, A will complete 75% of the work. So the answer is choice B. Okay, let's do problem number 6. ABC can alone complete a work in 15 days, 20 days and 30 days respectively. Okay, so this means that A alone can finish the work in 15 days, B alone can finish the same work in 20 days and C alone can finish the same work in 30 days. Now after working together for 5 days, A leaves. This means that for 5 days A, B and C have worked together, and then after 5 days A leaves. The remaining work will be completed by B and C working together in how many days? Okay. So first we have to know what is the remaining work. But before that, we have to know what was the amount of work done by when A, B, C working together for 5 days. Now, it is given that individually A, B and C can complete the work in 15 days, 20 days and 30 days. So now we can say that A's 1 day's work is 1 by 15. Similarly, B's 1 day's work is equal to 1 by 20. Similarly, C's 1 day's work, that is 1 day's work means the amount of work done in 1 day. So C's 1 day's work is 1 by 30. So this implies that A plus B plus C means A, B and C are working together. So A plus B plus C's 1 day's work means that the amount of work done in 1 day when all of them, that is A, B and C, are working together. This will be equal to 1 by 15 plus 1 by 20 plus 1 by 30. Okay, so this is equal to the LCM will be 60, and we have 4 plus 3 plus 2. This is equal to 9 by 60, which is equal to 3 by 20. 3 by 20. So the amount of work is the amount of work done in 1 day when A, B and C all are working together is 3 by 20. So now we need to find what is the work done in 5 days by A, B and C. So we can say A plus B plus C's 5 days work then will be equal to 3 by 20 multiplied by 5, which is equal to 3 by 4. 3 by 4 is the work done, amount of work done in 5 days by all of them, that is A, B and C are when A, B and C are working together. Now after 5 days A leaves, so the remaining work is work left the amount of work done in 5 days is 3 by 4, so the work left will be 1 minus 3 by 4, which is equal to 1 by 4. Now we have to find in how many days the amount of work which is left, which is 1 by 4, will be completed by B and C working together. Okay. Now B plus C's 1 day's work, B plus C's 1 day's work is 1 by 20 plus 1 by 30, which is equal to 5 by 60, which is equal to 1 by 12. So B plus C's 1 day's work is 1 by 12. Now we have to find in how many days B plus C will be when B and C are working together, in how many days they will complete the work of 1 by 4. So uh, there is no space left. Let me create some space. Okay, so now we can say that so B plus C's 1 day's work is 1 by 12, and so from this fact, how do we find how much time, how many days, or how much time B plus C when working together will take to complete an amount of work which is 1 by 4. So time taken by B plus C to complete 1 by 4 amount of work will be equal to uh, so we can say that 1 by 12 work is done by B plus C in 1 day. 1 by 12 amount of work. From this fact that B plus C's 1 day's work is 1 by 12, we can say that 1 by 12 amount of work is done by B plus C in 1 day. Then the whole work, that is one amount of work will be done by B plus C in 12 days. And then we can say that 1 by 4th amount of work will be done by B plus C in 1 by 4 multiplied by 12. This is equal to 3 days. So the remaining work will be completed by B and C when they are working together in 3 days. In 3 days. Now, a key concept to understand is that when you know that a certain person, a single person, or a group of person is doing a certain amount of work in 1 day, from this information, how will you find the number of days required to do a certain amount of work? A certain amount of work. So, okay, let me first solve all the problems. Then I will possibly discuss uh, some uh, some key concepts that was used to solve most of the in almost every problem. Okay, problem number 7. A and B working together can complete X% of a piece of work in 1 day. Okay, X% of a piece of work in 1 day. Now, a piece of work means a whole work, and whole work is always 1. So we can say that it is given that A plus B's 1 day's work is equal to X% of a piece of work. Now, a piece of work, that is a whole work, is always considered to be 1. So we can say this is to be X% of 1. So it is given that A and B working together can complete X% of a piece of work in 1 day. So that is this information I have written as A plus B's 1 day's work is equal to X% of 1, which is nothing but X by 100. Okay. Now it is asking then Y% of the work will be finished by them in how many days? Okay. Y% of the work, now of the work means the piece of work, which is 1. So Y% of the work will again be y by 100. Now, so x percent of a piece of work is equal to x by 100 into 1, which is equal to x by 100. Similarly, y percent of the work will be y by 100. Now, so we have to find in how many days y by 100 amount of work will be completed by a plus b, from the fact that a plus b's 1 day's work is x by 100. Okay, so we can say that um, so we can say that x by 100 work, x by 100 amount of work is done by a plus b in 1 day. This implies one amount of work is done by a plus b in uh, 1 by x by 100 using unitary method, which is equal to 100 by x days. That is, the whole work is done by a plus b in 100 by x days. So now we can say it is asking why in how many days a plus b will complete the y percent of the work. Y percent of the work means y by 100. So we can say now y by 100 amount of work is done by a plus b in 100 by x multiplied by y by 100 using Newton method. So from this fact, this fact was written in the form, it was written is written in another way, that x by 100 amount of work is done by is done by a plus b, that is a and b working together in 1 day. Now using unitary method, we can say that then one amount of work is done by a plus b in 1 by x by 100 days, which is equal to 100 by x days. So one amount of work is done in 100 by x days, then y by 100 amount of work will be done in 100 by x multiplied by y by 100, which is equal to y by x days. So the answer is y by x days. Okay. Problem number 8. The ratio of rate of work. The rate of work is given as amount of work done in 1 day. So the amount of work done in 1 day is the rate of work. It is given that the ratio of rate of work of A and B for a piece of work is 2 is to 5. That is the ratio of the amount of work done by A in 1 day and the amount of work done by B in 1 day is 2 is to 5. If A and B working together can complete the work in 5 days, then A alone will finish the work in how many days? Okay. Now we will have to use the concept of ratio and proportion. Uh, the ratio of rate of work of A and B, that is the ratio of amount of work done in 1 day by A and the amount of work done in 1 day by B is given to be 2 is to 5. So since the ratio is given to be 2 is to 5, so let A's 1 day's work is 2x and B's 1 day's work Now 1 day's work means the rate of work. Uh, so A is 1 day's work. We are assuming based on the given ratio 2 is to 5. We are assuming that A is 1 day's work is 2x and B is 1 day's work is 5x is 5x. So this implies that A plus B's 1 day's work, that is when A and B are working together, then the amount of work done by them in 1 day is will be equal to 2x plus 5x, which is equal to 7x. Okay. If A plus B's 1 day's work is 7x, we know from the second rule that if a work is done, if the amount of work done in 1 day is 1 by n, then the whole work will be completed in n days. Now we can write 7x as 1 by 7x, 1 by 7x. So now we can say that A plus B can complete the work in 1 by 7x days. From applying the second rule, we know that if amount of work done in 1 day is 1 by n, then the whole work will be done in n days. Using that rule, we can say that when we know that A plus B's 1 day's work is 1 by 7x, so 1 by 7x you can consider it as the capital N. So we can say that A plus B can complete the work in 1 by 7x days. Now it is given that A and B working together can complete the work in 5 days. So this implies that 1 by 7x is equal to 1 by 7x is equal to 5. 1 by x, so this implies that x is equal to 1 by 7 multiplied by 1 by 5, which is equal to 1 by 35. So x is equal to 1 by 35. Okay. So now it is asking then A alone will finish the work in how many days? Now x is 1 by 35, which means that A's 1 day's work is 2x, and x we have found to be 35. So 2 into 1 by 35, which is equal to 2 by 35. So A's 1 day's work is 2 by 35. So this implies now 2 by 35 can be written as 1 by 35 by 2. So if A's 1 day's work is 1 by 35 by 2, we can say that A alone, using the second rule, A alone can complete the work in 35 by 2 days, because we know the second rule says that if A's 1 day's work is 1 by n, in 1 by capital N, then the A alone can complete the work in n days. So applying that second rule, in this problem we are having A's 1 day's work is 1 by 35 by 2. So A alone will complete the work in 35 by 2 days, which is equal to now whenever you have an answer as a as an improper fraction, always convert it as a mixed fraction. So 35 by 2 when expressed as a mixed fraction will be 17 and half days. So A alone will finish the work in 17 and half days. Okay. Problem number 9. A and B working together can complete a piece of work in one third the time required by B alone to complete the work. Okay. A and B working together can complete a piece of work in one third the time required by B alone to complete the work. Then the ratio of amount of work done by A and B in one day is. So we have to find the ratio of amount of work done by A in one day and the amount of work done by B in one day. So let us assume that let B alone can complete the work in X days. So this will imply, since it is given that, so uh, uh, this implies that A plus B means when A and B are working together. So A plus B can complete the work in, it is given that A and B working together can complete a piece of work in one third the time required by B alone to complete the work. So if we have assumed that B alone can complete the work in X days, then we must have A plus B can complete the work in X by 3 days. One third of X is 1 X by 3. We have this. Okay. Uh, Now it is asking then the ratio of amount of work done by A and B in one day is. Okay, so we are having this, the ratio of amount of work done by A and B in one day. Okay, so now we can say that B's one day's work, from the fact that B alone can complete the work in X days, which we have assumed, we can say B's one day's work is equal to 1 by X. Also we can say that A plus B's one day's work will be equal to 1 by X by 3. Since A plus B completes the whole, A plus B means A and B are working together. So A plus B completes the work in X by 3 days. From this information, we can say that A plus B's one day's work is 1 by X by 3, which is equal to 3 by X. Now, A plus B's one day's work means A's one day's work plus B's one day's work. This work is equal to 3 by X. Now we know that B's one day's work is 1 by X. So we have A's one day's work plus B's one day's work is 1 by X. 1 by X is equal to 3 by X. So this implies A's one day's work will be equal to 3 by X minus 1 by X, which is equal to 2 by X. So we have A's one day's work. So now we have to find the ratio of A's one day's work and B's one day's work. So therefore we can say required ratio will be equal to um, A's 1 day's work divided by B's 1 day's work, which is equal to A's 1 day's work is 2 by x and B's 1 day's work is 1 by x. This is equal to 2, which is equal to this is equal to 2. So A's 1 day's work by B's 1 day's work is 2. So we can say the ratio is 2 is to 1. The ratio is 2 is to 1. Okay, let's do the last problem. Problem number 10. A is thrice as fast as B in completing a piece of work. Which means that if B is completing the piece of work in 30 days, then A will complete the work in 30 by 3, that is 10 days. Okay. Now, if B alone can finish the work in X days, then both A and B working together will complete the work in how many days? Okay. So, let's assume let B alone complete the work in X days. Now, since it is given that A is thrice as fast as B in complete a piece of work, we can say that A alone complete the work in X by 3 days. Fast means less number of days. So 3 as fast as B means that A will complete the work in X by 3 days, where X is the number of days in which B is completing the work. So we have this. So we can now say that A's 1 day's work is equal to 1 by X by 3, which is equal to 3 by X using the uh, first rule. The first rule says that if a work is done in n days, then if a complete work is done in n days, then the amount of work done in 1 day is 1 by n. Okay. Similarly, B's 1 day's work will be equal to 1 by x. So this implies that A plus B's 1 day's work, that is the amount of work done in 1 day when A and B are working together, will be equal to 3 by x plus 1 by x, which is equal to 4 by x. So 4 by x is the amount of work done by both A and B working together in 1 day. Now, oh sorry, it is in the problem only it was given that if B alone can finish the work in X days. Okay, so it was given that B alone can finish the work in X days. So it was not necessary to do the assumption. It was given. So it is given that we can say given B alone complete the work in X days. Okay. Now it is asking when both A and B working together will complete the work in how many days. So A plus B's 1 day's work is 4 by x. So this will imply that A, now 4 by x can be written as 1 by x by 4. So now we can say A plus B will complete the work in x by 4 days, using the second rule, where it says that if the amount of work done in one day is 1 by n, 1 by capital N, then the total work will be done in n number of days. So the answer is x by 4 days. So this brings to an end in solving the problems of exercise of assignment 1, which was given in the previous video, in the part 1 video, where I discussed about the two general rules of solving the problem of time and work. Now, it is very important that you list down the key concepts and formulas that was used in solving the set of problems, so that if you do that again and again, the concepts and formulas will remain in your mind for a longer period of time. Now, I have not prepared the key concepts. Let me see if I can write them down. Okay, so this is very important, very important to do. Very important very important key concepts and formulas used to solve the problems. What are the key formulas? Of course, the two general rules are obviously has been used. That is, if A can complete work in n days, will imply that A's 1 day's work, that is the amount of work done in 1 day, will be equal to 1 by n. So this is the first general rule of solving problems on time and work. So if A can complete a work, complete a work means a whole work. If A can complete a work in n days, then the amount of work done in 1 day, which in short is written as A's 1 day's work, will be equal to 1 by n. The second is of course the second general rule is that if A's 1 day's work, it is the second rule is the reverse of the, you can consider the second rule as the reverse of the first rule. So if A's 1 day's work is 1 by n, will imply A alone can finish the work in n days. The third is that if it is given that if amount of work done in 1 day, now this amount of work could be done, can be maybe it is done by a single person or a multiple persons. So if amount of work done in 1 day is, let's say, P, usually this P will be a fraction. So if amount of work done in 1 day is P, then we have to find then in how many then in how many days will q amount of work q amount of work be completed. This is another important concept that has been used many times in solving the problem. So if amount of work done in one day is P, now this amount of work could be done by a single person or a group of person. That is irrelevant. That will not matter. So if amount of work done in one day is P, then we have to find in how many days will Q amount of work be done. So the way we find is that P amount of work is done in one day. It is given that P amount of work, we know that P amount of work is done in one day. Now this the concept I used to find this is basically unitary method. So P amount of work is done in one day. This implies one amount of work is done in 1 by P days. 1 by P days. So this implies Q amount of work is done in 1 by P multiplied by Q equals to Q by P days. Now if you can remember this formula, the answer is Q by B, it is fine. But otherwise you can always use, you can always go by the fundamental concept, that is using unitary method. So in any problem, if you know that the amount of work done in one day is P and you are asked that how many days it will take to complete Q amount of work, then the answer will be Q by P. Remember that P is the amount of work done in one day. So this is another concept that will be used frequently in solving the problems. And also one very important thing is that a whole work has the value of 1. So this will be required to find the remaining work. So any partial work done will always be a fraction. So if you have to find what is the remaining work, then you always subtract the work done, that is the partial work done, from 1, since the whole work is considered to be is considered to be the value 1. So let's see, if let's say if X% of work is done, if X% of work is done, then how do we know what is the before that so if Q amount of work is done, this will imply that work left will be 1 minus Q. So in the problems where it is given that A and B are working together for 5 days, and after 5 days A leaves, then you have to find the remaining work. So to find the remaining work, if you know that the what amount of work is already done, so if that is Q, then the work left is 1 minus Q, because the whole work is considered to have the value 1. So An extension of this point number 5, or you can say an application, is that if it is given, if X% of work is done, this implies work left will be definitely equal to 1 minus 1 minus 1 minus the work done. If X% of work done means, what is the amount of work done? X% of the work. The work is X% of 1, because the whole work is considered to be 1. So this is equal to 1 minus X by 100, which is equal to 100 minus X by 100. So if it is given that X% of the work is done, then the work left is definitely 100 minus X by 100. Okay, so I think these are the few concepts that was frequently used in solving the problem. So I will end the video here. I hope this video was beneficial. If it is so, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve, before moving on to the next section, that is pipes and cisterns, I will solve the selected problems from exercise. What is the next exercise? I think 13A. Let me quickly check. Time and work. The next exercise is 13A. I will solve the selected problems of exercise 13A, which are based on the concepts that we have already discussed. That is the two general rules of solving problems of time and work. And then we will move on to the in understanding how do we solve problems on pipes and cistern. So that is all for this video. Thanks for watching, and until the next video, take care and bye.